Number 5. Jupiter's Great Red Spot. This mother of all storms is about 3 times the size of Earth.
We don't know exactly how the red spot formed. It's been there as long as we've been looking, as far back as the 1650s. So it was there before we started really paying attention.
The Great Red Spot is actually an ancient storm that's been spinning wildly for centuries. The supersized vortex towers 5 miles above the planet's cloud tops and dwarfs any storm system on Earth.
The 400-mile-an-hour winds measured in Jupiter's Great Red Spot are faster than some of the most powerful winds measured in tornadoes here on Earth. Yet tornadoes on Earth only last maybe a few tens of minutes, or at most a couple of hours, whereas Jupiter's Great Red Spot's been going strong for at least 400 years, and it's 3 times the size of Earth. Now that's one storm you don't want to get caught in.
Most tropical storms in Earth's southern hemisphere spin clockwise as our planet rotates. But on Jupiter, the Great Red Spot follows an unearthly path.
The Great Red Spot, which is in Jupiter's southern hemisphere, rotates counterclockwise. It's anticyclonic. And that's because it's a high-pressure system, unlike the low-pressure systems here on Earth associated with storms. So when you have a high-pressure system, the airflow is naturally the opposite to that of a low-pressure system.
The origin of this long-lived storm has baffled astronomers. But now, science may be on the verge of unraveling its stormy secrets. The Hubble Space Telescope recently snapped images of 3 smaller storms on Jupiter called white spots. Within 3 years, the 3 white spots merged to form one Earth-sized storm. Then, the unexpected happened.
Over the course of only about a week, the storm turned from white to bright red. It's now known as Oval BA, or sometimes Red Junior. Why it turned red and exactly how that happened is still a mystery.
Astronomers now suspect a similar merger may have also created the Great Red Spot. And like Red Junior, the ferocious storm may have originally been white. But as its speed grew faster, it began dredging up material from deep in Jupiter's atmosphere. One of the compounds could actually be a form of sulfur.
We don't fully understand why the red spot has its characteristic brick red color, but probably there are chemical compounds which are reacting with the sunlight and are giving it this color.
Astronomers have been closely monitoring the Great Red Spot. And in the last decade, they have detected an astonishing change.
We've been watching the Great Red Spot shrink and actually become rounder for some time now. Who knows if it's going to persist for another 400 years or maybe disappear entirely.
The Great Red Spot is by far the biggest storm in our solar system. But after leaving Jupiter, we head about 200 million miles in the direction of the Sun and have a close encounter with another barely believable wonder